Hello, welcome to our presentation about the eye tracking data collection method. I'm Simeon Brown, and I'll kick us off with the first half of the presentation and then turn it over to the real brains behind the operation, my partner Sophia Tarapas. So let's get started. So before we get into the nuts and bolts of eye tracking, I want to give you a little introduction, which is about the three different types of psycholinguistic research and data collection. All right. We have naturalistic data, which is what it sounds right? It's data or observations collected in the real world. This tends to be a bit more qualitative and descriptive. And then we have some prompted data. We have prompted production and prompted response, which eye tracking is part of. And this tends to be a bit more quantitative and it's contrived, right? It happens in a laboratory environment. Now, it's still very valuable data and it helps us understand things about how languages are used and acquired. But because it's very quantitative and very within a artificial environment, it doesn't give us a full picture. And I want you to remember that later when Sophia is talking to you about the limitations of this data collection method. Okay? So, what is eye tracking? You can probably guess from the name, right? Eye tracking tracks where you're looking. All right. There's different machines. Sophia's going to tell you some more about the nuts and bolts of how those machines work, but there's different machines that can see where we're looking for how long and how hard. Okay. This can track something when we're reading or looking at pictures or the real world. This can track our fixations and our saccades. What are those? Fixations are if you look at something for an extended period of time. And saccades are when you jump from one place to another. Okay, so I've given here a few examples of tracking eye movement when reading a text, and also when looking at a picture. By the way, that third one on the right, that's the tasks influence how the eyes move. And you see, like people looked at a picture and then it was tracked how their eyes moved when they looked at a picture and had to figure out how old the people in the picture are, or when they had to look at the picture and remember what clothes they're wearing. This picture is from a very influential study from a researcher named Yarbus, who I'm going to mention again in a bit. But yeah, so that's how it works. That's the broad overview. It can be used in many contexts. Of course, in medical studies, just when we're figuring out how our bodies work, in psychology, in marketing and product design. Of course, these days in UI and UX and how human bodies interface with computers and technology. But for our purposes, we're concerned with how it's used in psycholinguistic research, right? How it's learned, how it's used um, to figure out how humans learn and use languages. And there's a lot of history about that. Okay. And it's quite useful, right? Because think about it. Um, when I look at my beautiful wife, right? First, I look at her beautiful eyes. Then I look at her beautiful smile. Then I look at her beautiful heart. Okay. And And if you tracked this, it would tell you what are the most important things about my wife to me and in what order and how I think about them, right? So tracking our eyes tells us like what are the brain's priorities and how we process information and in what order. It also helps us process sources of ambiguity and how we figure out ambiguity, right? If I stare at something for a long time, I'm likely to have been considering it for a long time. If I return to it and go look at that and return to it and go look at that, I'm probably using those things to figure out my question. Okay. So this has a few applications for linguistic purposes. And of course, when we're looking at texts, when we're reading, our eyes are moving. We can track that. But also when we're looking at pictures or the real world, right? If we're getting some kind of input, either read or spoken input, and then looking around and reacting to that, this can tell us how our brains are processing language and interacting with the real world. More about that in a minute. A little history of the development of eye tracking research started back in the 19th century. Researchers started noticing and measuring how the eyes moved, when and why. A French person named Louis Havel observed those fixations and saccades that I mentioned. He was one of the first to observe and document those when we stare and when we jump. Okay, so he started observing those. By the beginning of the 20th century, people were trying to develop machines that could very precisely measure eye movement. And by the 1930s, a researcher named Mr. Buswell, from my home city of Chicago, by the way, Mr. Buswell developed a machine to track eye movements, and he released several influential studies about how people read and how people look at pictures. Fast forward to 1967, and that researcher, Mr. Yarbus, who I mentioned, he proved, it was a very important text, he proved that eye movement depends on the task that you're accomplishing, not the visual content that you're looking at. That may seem like a small distinction, but it's very important. Okay, so he did a lot of research and he proved that it doesn't matter what you're looking at, it matters what your brain is trying to do. And therefore, how your eyes move are an indicator of what your brain is doing. Okay, jump forward to the 1980s, and we have the release of the strong eye mind hypothesis. The strong eye mind hypothesis was a collection of data which proved that where your eyes are fixating are what your brain is processing right now. Therefore, wherever you're looking is what your brain is processing right now. That was accepted for a few years, but then was contradicted by some other studies which mentioned, hey, what about peripheral vision? The stuff you see out of the corner of your eyes. What about things that you're imagining in the future or the past? Your brain's also processing them. And this introduced an element of debate, which really gets out in the weeds, and it's beyond the purposes of this presentation. But yeah, these are the kind of arguments that these people have in this field. Today, in the 21st century, we use it a lot. It's a very valuable data collection tool. Of course, modern portable electronics and the AI revolution are introducing new tools all the time. Neural networks are giving us new ways to process this data and make guesses about how the brain works based on that. Okay. A few use cases, and Sophia's going to tell you some more detailed use cases, so I won't get into these, but just to tell you how it's used. As I mentioned, in reading, it can be used to understand syntactic processing. That is how the brain organizes grammar or sentence structure, right? How your brain, looks first, next, then, finally. And what is that first, next, then, finally? Eye tracking can show us that. A really interesting one was sorry, how can I move my camera here? There we go. Down at the bottom, we've got the shared and separate systems processing and bilingual language processing. This was a cool study. They took bilingual speakers and gave them tasks such as they might take a Russian speaker and have them look and identify the shark. All right, and there's a group of pictures. One of them is a shark. And they say, point out the shark. However, in Russian, the word sharik means balloons. And somewhere else there's a picture of balloons. And if they say, sir, please find the shark, the Russian man will first look at the sharik in his own language, the balloons, and by measuring how his eyes jump from that picture to that picture, we can measure the lag time in how our brains process things bilingually. So it's a really interesting tool, lots of use cases. And with that, I'll pass it over to Sophia, who will tell you more about how we can use it and what are some of the limitations.
Okay, so there are two types of eye tracking technology. This is the first one in which the participant actually wears something on their face that are like glasses. So it's an eye tracker that consists of cameras, illuminators, and algorithms, and it records what the user is looking at. They take high reduction images of the user's eyes and the patterns, and they process algorithms to find specific details in the user's eyes and reflection patterns. And they're looking at the user's eye position and gaze point and calculate them using something called a sophisticated 3D eye model algorithm. And the second one works very similarly. It's still looking at the eye position and gaze point and processing the images, but instead of the user wearing it on their face, this comes from the device that they're looking at itself. So this I think is a lot more user friendly. I think it's better because it doesn't distract the participant as much, but it might be more expensive in some cases. So, the role of the researcher. So, if you were to use eye tracking in your research, what would that look like? What would you be responsible for? So, first of all, you would set up the equipment. You'd have to make sure there's good lighting. You would have to minimize distractions, and you would need training on this. This is technology that requires a bit of technical expertise. And then you would calibrate it. So you guide the participant to make sure they know what they're doing and you adjust the system as needed. And then you monitor the participant to ensure that they remain in optimal position, that they're not moving around too much, etc. And then extracting the data, this comes from the system itself. So it's not like you have to put together the data, the system is going to do it for you. But you are the one responsible for looking at that data and then interpreting the patterns. So it will give you the numbers, but you have to kind of decide what they mean. So, some examples of this. My first research example is predicting native language from gaze. This is actually really interesting. So, researchers wanted to find out if a person's native language can be predicted based on their eye movements while reading in English. So, they looked at fixations, which is where the eyes stop, saccades, which is the eye movements between those fixations, regression patterns, which is where you revisit certain words or phrases, and pupil dilation, which reflects cognitive effort. I did not know that before reading this. So they looked at those things and they found, for instance, that Greek and Russian speakers had longer fixation durations. German speakers tended to have more regressions, and Spanish speakers skipped words more often. So that could be, for the Spanish speakers, it could be because there's a lot of cognates between Spanish and English. So by looking at these things, researchers were able to use eye tracking to predict correctly what the participants' native language was in 67% of cases. So, the implication for this is that L1 reading habits influence L2 processing. And if we understand how participants are able to read in English based on their L1, we might be able to provide them with more personalized reading support as teachers. And I just wanted to include some data. This math is above my head, but I just wanted to include some of the data that comes from the system that tells you exactly how they're calculating this. It's very complicated, but I just wanted to show that really quick just to give you a visual aid. The second research example I have is an article called An Eye Tracking Study of Learned Attention and Second Language Acquisition. And researchers wanted to know how prior linguistic experiences shape how L2 learners allocate attention to different types of linguistic input during learning. So they tracked the participants' eye movements while they engaged in tasks that involve processing grammatical structures in their second language. Well, in this case, that would be English, of course. And they found that learners' L1 processing strategies affect their L2 focus, and that advanced learners tended to pay more attention to grammar, while beginners focus more on word meanings. And the implication is just with the last one is that we can provide personalized reading support depending on the level. So in our instruction and scaffolding should reflect our students' needs. So maybe if beginners are focusing more on word meanings, perhaps we need to give a little bit more explicit grammar instruction in that case as well. Um, all right. And my last research example that I have for you is using eye tracking as a tool to develop L2 lexical knowledge. So, researchers wanted to know how L2 learners develop lexical knowledge or vocabulary. And so they monitored where and for how long learners fixated on specific words when reading a passage with highlighted target vocabulary. All right. So they had a passage for the participants to read, the vocabulary that they wanted the participants to learn, they drew attention to it by highlighting it. Okay. And learners who paid more attention to vocabulary had better retention and comprehension. I don't think that's particularly surprising. But the manipulation of attention led to an increase in lexical knowledge. So by drawing the learner's attention to those words, they were able to retain better. And learners tended to focus more on words that they didn't know. And again, we know that they did this based on the amount of time that they looked at the word. And the implication is learners benefit from techniques that guide their attention towards target vocabulary. So it's important as teachers that we make it very clear what we want our students to learn. And I think that goes for anything, grammar as well as vocabulary in general. We should always make it's the whole point of doing our objectives, right? To make sure our students know what they should be focusing on. So I think that makes sense, but it's interesting to see a study in which eye tracking kind of confirms that. So eye tracking, talking about the strengths in general of using it as a data elicitation tool, it shows us patterns of attention allocation and information processing that we can use to develop more engaging and effective language instruction. So as the research said, we learn how each individual reads, and we can use that to provide more personalized support. It can also differentiate between syntactic and semantic processing. So we can see if a learner, for instance, needs more help with grammar or vocabulary. And the data is quantitative, it's objective. So you can't really influence it by opinions or beliefs. It's giving you numbers, and it's in real time. So those are our strengths. It's a very cool technology for sure, but there are limitations as well. The equipment can be quite expensive, so this isn't accessible to everybody. It requires technical expertise. You do have to learn how to use it. It would never happen in a naturalistic setting. In a normal classroom, people would never be wearing something over their eyes that's recording them as they go. So that could definitely affect how they're reading. Eye movements can be interpreted differently. So, even though this is objective in the sense that it's telling you how long they're looking at the word and which word they're revisiting, the eye movements, it's not directly telling us what's happening to them cognitively. We're making a guess based on their eye movements, what's happening cognitively, but it's not like we know that for sure. I also don't think it takes into account disabilities or neurodiversity. I assume if someone has any issues with vision or something like that, they probably would be excluded from a study, but I'm not sure. And then neurodiversity, it's like, how can you really say if a person's revisiting a word because they didn't understand what it means? Or perhaps they just have issues with reading comprehension in general and just need more time to process the text, something like that. And then in general, this is not comprehensive at all. We really can only use it to track participants' reading habits. This doesn't take into account really any listening, speaking, or writing abilities. So we really can't use this to make any big general assumptions about how a learner acquires an L2. This is only focused on one specific area. And so with that, Our recommendation is that eye tracking should be combined with other research methods to provide a more comprehensive understanding of language processing. So, this should not be the only thing, as I said before in the limitations, this should not be the only thing used to make assumptions about how an L2 is acquired. However, it is a really, really interesting tool that I would be very eager to use someday if possible. So that's all I have for you. Here's our sources. Thank you for listening, and I hope you have a great rest of your day.